All right, we're going to start in on page 87 of our notebook, and we're going to look at similar right triangles. And with this, we're still going to use some of the properties that we did with the right triangle stuff, with solving right triangles and the triangle trig. But we're going to look at similar, comparing more than one triangle with it. So on page 87 here, I'll share my document camera and we'll get going. We only have a couple problems here this time. All right, so page 87, we're going to look at similar right triangles. Okay, go ahead and split your page into thirds here. So we got 3 boxes. And in the top one, we're just going to look at kind of some notes here. So I have this triangle. This is a right triangle there. We're going to call this triangle A, B, C. And with this triangle, I'm going to look to split this right here. And this will be point D. And what this does is it creates 3 triangles that are all similar to one another. Okay, so you have triangle ABC, which is the large one, is similar to triangle BDC, which is similar to triangle ABC. Okay, so all 3 of these triangles are similar, which means they are the same shape, which is a right triangle, but they are of different sizes. Okay, so they all have congruent angles. But proportional sides. And we talked about this in the last unit, but with this one, we're specifically only going to be looking at right triangles, okay? All right, so let's look at this first example here. So this is E, H, F, G. And then we'll put some sides on here. This is 3, this is X, this is 4, this is 5. So with these, it can be kind of difficult to see what side goes with what on these triangles. So I recommend that you redraw these triangles out into kind of a small, medium, and large format. That way you can really see what side is going with what. Okay, so on these, here's our small triangle. Here's my right angle. So it looks like the hypotenuse is 3. Okay, and the long side here between the hypotenuse and the 90-degree here is X. Okay. And then on our medium one, my right angle would be up here. The hypotenuse is 4. The short side would be X, and the long leg would be 5. And then in our large one, it looks like we've got a 3, 4, 5 right triangle. So 3, 4, 5. And on this, all I want to do here is find X. And there are several different ratios you can use to find your X. And I'm going to look at 2 of them here. I'll do the hard one first, or maybe the more difficult one here first. So if we look here, hold on, let me, so X is this side right here. Okay, so if I use another triangle, I need to use a triangle that has that side. Okay, so I actually can't use this side or this triangle because it doesn't have this side. And that actually eliminates the one, the hard one, because I won't have 2 X's. Okay, so this one is gone. I'm not going to use that. So I'm only going to use this one. So I'd say X over 3 equals, and you can actually use any of the other 2. So 4 over 5 or 5 over 4. I'm going to use 4 over 5. Yeah. Again, it doesn't matter which one you use. So we're going to multiply the whole thing by my common denominator, which is 15. And then I distribute that thing in there. So 15 divided by 3 is 5. And 5 times X is 5X. 15 divided by 5 is 3. 3 times 4 is 12. Then we'll divide by 5. And X equals 12 over 5. Okay, the hard way that I mentioned before, you would actually have an X here and an X down here. Okay, and you would end up having an X squared, which in order to get rid of an X squared, we know that you just take the square root of it. But if you write these out here separately, you can kind of see that you won't need that. All right, the next one here, and this is our last one. We only got a couple because we did a whole section on similar triangles. Okay, so here. Okay, on this one, we're going to find the value of X. Plus, they want us to find the scale factor. Okay, so again, I'm going to draw these triangles out separately. And notice here that they gave me this angle is 45. So is this angle and this angle, they're all 45. So we actually have a 45, 45, 90, 2 45, 45, 90 right triangles, which allows us to use the special right triangle properties. So there's the small one. And your drawings don't have to be perfect here. There's the large one. This side is 12 and this side is X. This side here is 4. That's all they give us. And I know that this side is X because X is in the middle of that long side. X is not in the middle of this one and it's not in the middle of that one. Okay, so since this is a 45, 45, 90 special right triangle, if we remember the rules here or our formula triangle, this was X, X, X radical 2. Okay. So I actually know that if this leg is 4, kind of change colors here. Do this color. This side is 4. This side will also be 4, same. And this side over here would be 4 radical 2. Okay, because you multiply by radical 2. Over here, this leg is 12, so this leg is 12. And when I go to x, the hypotenuse, I just multiply by radical 2. So x is actually 12 radical 2. Okay, I didn't have to set up ratios like in the one before because I know this formula triangle. Now it wants the scale factor. Okay, so our scale factor. And if we look at this, 4 and 12 are the same sides or corresponding sides here. We can do a 12 over 4 and 12 divided by 4 is 3. So our scale factor in this case would be 3. Or if we flip that upside down, it would be 1/3. So it just kind of depends on the direction that you're going. Okay, so I will go ahead and upload a practice for you on similar right triangles, and then you will have a quiz on it. We are also going to start reviewing for our right triangle test. So the next video will be doing that, and we will take a look at that review in class as well. So if you have any questions, feel free to reach out. And if not, I'll see you in the next lesson.